Friends, in this video we will try to understand why COP of heat pump is more than COP of refrigerator. How is that possible? How coefficient of performance of heat pump is more than coefficient of performance of a refrigerator? And the conditions are same, means both the heat pump and refrigerator are working between the same temperature limits. Suppose I draw a simple block diagram. Say this is a heat pump and this is working between two temperature limits. These are the two reservoirs, two sources of heat and maintained at different temperature. This is the heat pump, and I will draw another block diagram between same two temperature limits, and the only difference is the between the device operating between the two temperature limits is one is refrigerator and one is heat pump. So why is that possible? How is that possible? Coefficient of performance of heat pump is more than coefficient of performance of refrigerator. So I will write COP one by one. First I will write COP for heat pump. So the desired effect of heat pump is, what is the desired effect? What is the output in case of heat pump? I will write here output or desired effect. Desired effect, desired effect means the result that we want. So heat pump always heats up a space. We want heating of a space or an area by heat pump. So in case of both the heat pump and refrigerator, there would be a work input, right? Work input, and these are operating between two temperature limits. This is the temperature of the body maintained at lower temperature, and this is the temperature of the reservoir or area maintained at higher temperature. Again same, this is the temperature of the space maintained at higher temperature, and this is the temperature of the space maintained at relatively lower temperature TL, and both need work input, right? Work input as energy. Why? Because heat has to be extracted, heat has to be absorbed from this space maintained at lower temperature. So QL is the heat absorbed from this space, and QR or QH is the heat rejected to this space, because we want heating in this space, and this is the desired effect of heat pump. And in case of refrigerator, this is the space where we want cooling, right? And what is refrigerator doing? This is continuously absorbing heat from this space and thereby able to maintain this space at a relatively lower temperature. That is what is seen in refrigerator in case of summer. And this is the space where heat is being rejected out, so QH. So the desired effect of heat pump is heating up of a space. And in case of refrigerator, we will again write desired effect or output of refrigerator is cooling. So you have just seen the difference between the desired effect of a heat pump and refrigerator. Whereas we want heating in case of heat pump, we achieve cooling in case of refrigerator. So one by one, why not we start writing COP of refrigerator first? So we have just seen, if you have missed to see how to find out, how to calculate, how to determine coefficient of performance of heat pump and refrigerator, just see my previous two videos, the link of which I will put in the comment. So don't miss to go through those. The easiest method, the easiest approach I have tried to share with you in the videos. So without wasting time, just write COP of refrigerator. So in the numerator, it comes TL, that is nothing but temperature of the body, temperature of the space maintained at lower temperature, upon TH minus TL. This is the same thing. What is the refrigerator doing? This is continuously rejecting heat. First, this is absorbing heat from a space, and this is rejecting out to the system from the system, and thereby it maintains this space at a lower temperature. That is what seen in refrigerator. So again we will write coefficient of performance of heat pump. Here in case of refrigerator, the desired effect is cooling, so TL will come in the numerator, and in case of heat pump the desired effect is heating up of the space. We want a space to be heated up, like in winter we use heaters, right, that heats up the space relative to the surroundings. If we compare the temperature with respect to surroundings, the inside space is hotter. So that is what is achieved by virtue of heat pump. So in the numerator it will come TH. Upon denominator it's same in case of refrigerator and heat pump. So now our motive, the objective was, we are trying to understand how COP of heat pump is greater than COP of refrigerator. How is that possible? So we have just written the two COPs. This is 1 and this is 2. So if we add plus 1 to COP of refrigerator, COP of refrigerator plus 1, what are you gonna get? So COP of refrigerator is TL upon TH minus TL plus 1. If you further simplify this, TL plus TH minus TL upon TH minus TL. So this TL plus and minus will cancel out each other. So what you are left? You are left with COP of refrigerator plus 1 is equal to TH upon TH minus TL. So you have just seen COP of heat pump is TH upon TH minus TL. Let me put this in bracket. So you have got, again, this is what? This is nothing but COP of heat pump. We can further write COP of heat pump is equal to COP of refrigerator plus 1. So we are getting heat pump more than COP of heat pump more than COP of refrigerator by unity. So at least it will be greater than unity. So it is greater than refrigerator COP by unity. So the phenomenon that is acting here is the virtue, by virtue of the desired effect, the COP is getting greater than COP of heat pump is getting greater than COP of refrigerator. So this is the actual phenomenon and the reason behind the COP of heat pump greater than COP of refrigerator. We can further simplify. In the exams you are often asked, in like the options would be given, one option would be straight away this, that COP of heat pump is equal to COP of refrigerator, or COP of refrigerator is equal to COP of heat pump plus 1. So you have just seen that heat pump COP is always greater than COP of refrigerator. So this can never happen. This can never be the case. So you can eliminate this, that this is always false. This option, if you see this option, you can just eliminate this. So by this you can further simplify this as COP of heat pump is greater than COP of refrigerator. So two cases, like in the exam you can find the two options if you see questions related to heat pump and refrigerator COP. And why this is happening? Because in order to achieve cooling, in case of refrigerator, in order to achieve cooling, you are just absorbing heat, right? You are extracting heat from this cold body space maintained at lower temperature. So this is the heat absorbed from body at a lower temperature. So QL, right, it is the heat absorbed from this space. And in case of heat pump, what is happening? In order to heat up this space, you are giving work input as well as heat is being absorbed from a body and maintained at a lower temperature. So here arises the difference. In case of desired effect, in case of heat pump heat pump, I will write here, heat pump, you are giving work input as well as heat is being absorbed from body maintained at a low temperature, and that is how you are able to heat up this space. Means qh is qh can only be given to this space when work input is applied as energy source and this heat is being extracted or absorbed out of this body maintained at a lower temperature. So this is the case in case of heat pump, and in case of refrigerator, in order to achieve cooling, here the objective is to heat up the space, the object desired effect is heating, right? And in case of refrigerator, the desired effect is, or the outcome or the output we want is cooling. So in order to achieve cooling, we have to continuously absorb heat or extract heat out of the body maintained at low temperature. So you can conclude this is the one what you can say, quantity that is common in the two. The only difference, the only quantity that is arising the difference is work input. That is why coefficient of performance of heat pump is greater than refrigerator, because this is the one that is doing the change, that is bringing the difference, right? So here, that is why coefficient of performance of heat pump is greater than coefficient of performance of, because of the heat, because of the desired effect, because of the outcome output that is being achieved, because of the effect that we want. I hope you got the idea, and I have just tried to put it in simpler words, that how is it possible that heat pump is giving more coefficient of performance, right? So in exam you can either see this thing plus 1, if you add plus 1 to COP of refrigerator, you will get this, or simply COP of HP is greater than COP refrigerator. So this is very common. You often see these type of questions in exam related to refrigeration and air conditioning. So just mug up and try to understand the concept behind this. I hope this video helps most of you, and we will meet again in the next video with more concepts and logics on mechanical engineering that you often see in your exams like state PSC AE, SSC JE, RRB JE, and other exams. Thank you. We will meet again.